Welcome to the third session of the online Permagarden Foundations course, Water Management for Garden Resilience. In this session, we will explore how to build water management systems that provide plants with consistent water while also protecting them from flooding and waterlogging. We will be introduced to several concepts that can help us use water efficiently, including the three thieves of water: slowing, spreading, and sinking water, and working on control. We will see examples of Permagarden water management techniques. Finally, we will explore how to connect water management strategies together to build climate-resilient gardens.
There are three ecological building blocks to a permagarden: water, soil, and biodiversity. In this session, we will review water. Water is critical for plant growth, but having a consistent, easily available supply of water is often a challenge for households. Too often, households are faced with a situation where water is unavailable, or too plentiful, or too costly to obtain. Permagardens use techniques that aim to prevent all of these problems before they occur. First, let's stop to think for a moment. Can you think of water management techniques that make sure water is available to crops during the dry season or a drought, protect crops against too much water during a heavy rainfall or flooding, and are inexpensive and applicable to many environments? Take a moment to note down all the techniques you can think of. Permagarden strategies for water management are based on sound agroecological principles and involve simple but effective techniques to capture and store water in the soil so that it is consistently available to plants. These techniques require time and labor but are inexpensive and applicable to many environments. Having an effective water management system is one of the minimum standards for permagardens. Permagardens primarily use water from two sources: rainwater and wastewater. These two sources of water are typically the most accessible to resource-constrained farmers, but they are not often effectively captured for garden production. Permagardens use multiple connected strategies to capture this water and store it in the soil even well into the dry season. Permagardens also use multiple strategies to protect against water loss. There are three thieves that can steal water from our site: slope, sun, and wind. When it rains, any slope on our land will cause water to run downhill away from our gardens. And strong sun and wind further increase water loss in soil and plants. Throughout this video, we will see how to improve our water management by addressing the three thieves. Let's start to look at the strategies we use in permagardens to capture and store rainwater. Rainwater falls on every household's land at some point throughout the year. Even a small amount of rain can generate a surprising amount of water. When 1 millimeter of rain falls on 1 square meter of land, it yields 1 liter of water. So if we have a typical rainfall of 25 millimeters falling on a 20 square meter garden, we would get 500 liters of rainwater, or the equivalent of 25 jerry cans that we could harvest on that plot alone. In many areas, farmers are finding that rainfall is becoming both unpredictable and extreme. Many are experiencing extended droughts or unexpected dry spells. And when it rains, there is often too much water at once, causing flooding and damage to crops. A good rainwater management system, therefore, has to be adapted to its context and needs to capture and store as much rainwater as possible, while at the same time minimizing the damage that can be caused by fast-flowing water or standing water. The Permagarden approach recognizes that the most effective and least expensive place to store water is in the soil. In this way, permagardens avoid the need for expensive inputs to store and transport water to crops, like rainwater tanks and irrigation tubing. So how do we capture and store water in soil? We apply a principle known as slow, spread, and sink. First, we slow down rainwater as it moves across the landscape. We then spread it evenly over an area where we want to grow our crops and allow it to sink deep into the soil where plant roots can access it. To do this, we need to work with the contours of the landscape. The contour of the land are the points that are at equal elevation, in other words, perfectly level. Even land that appears to be perfectly flat still contains small contours or points at different elevations that cause water to run in one direction or another when it falls on the surface. Here, you can see an example of what it looks like to work on contour. As you can see, the contour line is not usually a straight line. When we work on contour, we can capture the rainwater that falls on our site instead of letting it run off. Working on contour also helps us to slow the flow of water, spread it out across the area we want to be productive, so that it can then sink deep into the soil. Contours are invisible to the naked eye, so we use a tool called an A-frame to help us find them within the landscape. An A-frame can be built entirely from local materials that are easily found in most places. 3 pieces of wood or bamboo are tied or nailed together to form a sturdy A shape. A string with a rock tied to the end is hung from the top so that it swings freely. Then it must be calibrated to ensure it works properly. You can find more information about how to build, calibrate, and use an A-frame in the supplemental materials of this session. We use the A-frame to mark the contour of the land before starting to dig.
Tunatumikisha kadre A. Kama hii inakuwa katikati, manake hapa na kwingine pale kuko kufasi moja. Tunasikilizana? Manake hapa kama maji inafika, inaweza kuikala na inashuka polepole kwa udongo. Na njoo kitu tunatafuta kui shamba yetu. Tunasikilizana? Sasa hapo tunaweza kutia pike. Mama tia pike pale. Gisi hapo iko sawa sawa. Unatia pike na hii. Sawa. Asanti. Tumeona gisi tumeisha pima hapa. Mwingine mama mmoja atakuya komsa aendeleshe, tutafute mapoint na hii konturu yetu mpaka kwenye tutaongoza mai. Basi mama pima. Okay, asante. Tunaangalia kama inafika kwa sawa. Mama tunatia pike pale. Okay. Tuko tunaona gisi kwa tunafanya huku. Hapo bado. Hapo sawa. Mama unaweza kutia tena pike. Haya, tunaendelea. Tunaendelea. Tunaangalia mzuri. Bado kufika. Mama angalia nani yako kati.
So, we've reviewed why it is important to work on contour and how we can use an A-frame to guide us. Now, let's look at the 3 key techniques that use contours to slow, spread, and sink rainwater into our soils so it can be used by our permagardens. The first technique we will learn about is called a swale. A swale is a water harvesting ditch that is dug on contour with a berm on the lower side. The berm is a retaining wall of soil that traps water and nutrients so they have time to sink underground. Water running into the swale spreads out evenly because the swale is on contour. In permagardens, a swale is often placed upslope from the garden beds to capture rainwater as it moves downhill. The swale also stops water from flowing directly through the garden bed, which causes topsoil to erode away. A second technique is to dig the beds themselves on contour, in addition to digging them deeply. You will learn more about digging beds deeply and on contour in session 4. And last, we can use contours to capture and store water at the base of trees that provide fruit, shade, green manure, or any other resource considered useful by a household by using a technique called half-moon berms. A half-moon berm is a curved berm that is placed on the downslope side of an established or newly planted tree. As water flows downhill, water and nutrients are captured by the curved berm and sunk into the area around the tree's root zone. To prevent our swales and half-moon berms from overflowing with water during heavy rainstorms, we make sure the structures are interconnected using spillways that pass water from a swale or half-moon berm to the next structure downslope. By connecting the structures, the spillways allow excess water to safely overflow when needed. By using these 3 strategies, swales, garden beds on contour, and half-moon berms, we have protected our rainwater from the thief of slope. We now need to protect our rainwater from the thieves of sun and wind. Sun and wind dry out our soils and increase water loss in plants through evaporation and transpiration. Keeping our soil covered by plants and mulch helps to protect from this water loss. We can also create shade structures or plant trees on the western sides of our gardens to shed soils and plants from the most intense afternoon sun. This is a particularly useful approach in dryland areas. Planting trees can also help to shield plants from strong winds. Aside from rainwater, another key source of water for permagardens is wastewater, also known as grey water. This is an often overlooked resource that can make a huge difference, particularly for dry season production. We will review 2 techniques to use wastewater now. Our first wastewater management technique is called a mulch basin. A mulch basin is a hole dug next to where dishes are washed or next to the bath or shower. The hole is filled with mulch to filter the soap in the water, and then water-loving plants like banana, cassava, or sweet potato are planted on the berm around the basin that was created by the excavated soil. A mulch basin can transform an otherwise barren place in the compound into a productive space that can provide extra food, particularly during the dry season. Our second wastewater management technique is simply to place the dishwash stand or other activity that produces wastewater next to our garden beds. Place rocks underneath the dishwash stand to help filter the water and prevent erosion. Alternatively, dig a swale next to where the dishes are washed and channel the water into the swale. The swale can then be planted with useful crops. The resilience of a permagarden comes from having not just 1 or 2 of these water management strategies in place, but multiple strategies that are all working together. Let's have a look at what this looks like in this compound. This household has started with digging a swale above their garden beds. This is the highest point of the permagarden. The swale slows, spreads, and sinks water into the soil for the benefit of the garden beds downslope. In case there is a heavy rain, the household has dug a spillway to direct excess water into the half-moon berms, supporting some useful trees. Note also that the household has placed their swale and gardens downslope from the cow and chicken pen so that the swale will capture any nutrients that are being picked up by the water flowing downhill. These nutrients will also benefit the garden, as we will hear more about in session 4. The household has also dug their beds on contour with deep soil preparation and leveled them so that water falling on the beds sinks down rather than flowing off. They have also mulched their garden beds to protect against water loss caused by sun and wind. To ensure that all water flowing down the hill and out of the swale spillway is used efficiently, this household has dug half-moon berms around all the trees. The overflow from one half-moon berm feeds into the next, which ensures that the water can be used equally by all the trees. Finally, the household has placed a swale next to the dishwash stand. The swale is filled with mulch and planted with sweet potato and cassava. The swale is also connected to the trees using a spillway so that any overflow from this swale feeds into the plantation. By using multiple connected strategies, this household has created a water management system that efficiently uses all the rainwater and wastewater available to boost garden production even without steady rains. As we conclude the session, let's stop and take a moment to review all that we have learned. Pause the video so you can write down your answer to the following question or discuss with your group. How can an effective water management system lead to a more climate-resilient garden?
In conclusion, an effective water management system works to create a consistent supply of water for crops year-round, while also mitigating against the damaging effects of too much water. Permagardens use multiple strategies to capture as much rainwater and wastewater as possible at this site. They work on contour to slow, spread, and sink water into the soil so that it can be effectively used by crops. They connect swales and berms with spillways to ensure all water is used efficiently and excess water is directed to where it is less damaging. And finally, they protect against water loss from sun and wind by covering soil with mulches and leaving plants and planting shade trees. That completes the learning for Session 3, Water Management for Garden Resilience. Now, let's continue to Session 4, Building Living Soils.